Hello everyone, I'm Nouran and this summer I'm working on improving configuration cache unlock contention in key Gradle plugins. As part of my Google Summer of Code project, I'm excited to share with you what I have learned, accomplished, the challenges I faced, and what's coming next. A bit about me, I am junior computer engineering student at Ain Shams University in Egypt. I was team leader at Digital Egypt Pioneers Initiative. I had the chance to participate in several innovation programs like Hackathon 24, where my team reached the finals, and even Pharma Hackathon, where we worked on healthcare mobile apps. I also ranked in the top 3 projects in Al Arabi Hackathon for designing a motivation system. You can always reach out to me using my email or check out my work on GitHub. So yes, my Google Summer of Code project focuses on adding configuration cache support. With configuration cache, the goal is to store the result of the configuration phase after the first build. Then on the next build, Gradle can skip configuration entirely and reuse the cache, leading to significantly faster builds. My work involved refactoring plugins to make them compatible with this mechanism and replacing runtime project access with cache-friendly data models and ensuring tasks are isolated, stateless, and reliable for caching. This improves both performance and developer experience. This slide gives an overview of how the configuration cache works in Gradle builds. Gradle builds go through 3 main phases: initialization, configuration, execution. Normally, during the configuration phase, Gradle evaluates all build scripts, configures the project, and generates the task graph, which determines what tasks to run. On the first run, as you see on the left, this task graph is built from scratch. Once complete, Gradle stores this configuration data into the configuration cache. Then on a subsequent build as shown on the right, if the requested tasks are the same and no changes have been made to inputs, Gradle skips configuration entirely and reloads the tasks graph directly from the cache. This significantly reduces build time by avoiding redundant configuration work. So in short, configuration cache helps Gradle remember what it did before and reuse it efficiently when nothing has changed. During my first coding phase, my main goal was to begin adding support for the configuration cache in key Gradle plugins. I contributed 2 major plugins. I opened a PR in Gradle Length plugin where I proposed a solution to fix partially configuration cache compatibility, and PR in Play Framework plugin. These pull requests involved refactoring how tasks interact with project model and making sure they no longer access it at execution time, which is a common violation of configuration cache requirements. One of the biggest challenges I faced was the steep learning curve. I had to understand Gradle internals in depth, learn how to detect behaviors that break cache compatibility, and explore multiple ways to fix them while maintaining plugin functionality. Um, this phase really built the foundation for the improvements that followed. Now it's time for the demo. I'm using Composite Build to test my local changes. Now I'm gonna test the original plugin itself. Yes, I added to build a Gradle and turn on configuration cache in Gradle to birds. I'm using it testing it in sample Gradle build project. Yes, it failed. Now I'm going to uncomment my include build, my local changes, and trying to run it. In the first build, it takes 7 seconds, and in the next ones, it takes less than 1 second. My key learnings. Through this project, I have gained a much deeper understanding of how Gradle's build lifecycle works, especially how the configuration and execution phases affecting caching behavior. One of the key things I learned was how to extract all necessary project data during the configuration phase so that nothing incompatible is accessed during execution. I also learned the importance of avoiding non-serializable objects and how to design tasks and services to be lazy, stateless, and cache-friendly, which is essential for configuration cache support. I got hands-on experience with Gradle Taskit to verify plugin behavior in real-world scenarios. Overall, this project taught me safe data handling, how to structure tasks properly, and how to work within Gradle constraints to deliver more efficient builds. My next steps is to continue enhancing configuration cache compatibility for more community Gradle plugins. One key area is identifying and fixing any remaining patterns that break cache compatibility. I also hope to collaborate closely with plugin maintainers, not only to get my contributions integrated, but also to help ensure the plugins remain cache compatible in the long term. Finally, I'll be working on documenting my findings, challenges, and patterns so future contributors can build on this work more easily and contribute to better plugin stability and performance. Finally, thank you. I'd like to thank my mentors and Gradle community for their continuous support throughout this journey. And a special thanks to Google Summer School program for making this incredible learning experience possible and empowering students like me to contribute to open source projects. It has been a truly inspiring journey, and I'm grateful to have been part of it. So, thanks.